Okay, 2.4, good definitions. Okay, so there's three different things that make a good definition. First one is it uses only words commonly understood, so just regular everyday words. Defined earlier words, so ones that we've already talked about in the book and put a real definition with, or purposely undefined words, which in our book would be point, line, and plane, and then your commonly understood undefined terms like the, it, is, that kind of thing. Okay, next one there, it accurately describes what's being defined. Well, that makes sense, right? Because it's not a real good definition if it's not even accurate. So that's the second one. Third one, it includes no more information than is necessary. So that basically means it's not running on and on and on and on, just going over the same exact thing. So just clear cut to the point. Okay. So the first thing we've got here is on page 77, they have definition of midpoint, so jot that down. And it says the midpoint of a segment AB is the point M on segment AB with AM equaling MB. Okay, so kind of what that means is if we've got a segment here, AB, the midpoint, M, would be a point where our distance from A to M is the same as our distance from M to B. That's how they're getting AM equaling MB. Okay, so that would be an example of a good definition because we've already defined segment. Point is left undefined, and those are really the only words in there that aren't like just everyday words like the, of, that kind of thing. Okay, so now what we're going to do is we're going to use that definition of midpoint, and it says, is C a midpoint of segment AB by definition? Okay, so if we're looking at this triangle here, they want to know if this point C is a midpoint of this segment AB. Okay, these little lines here mean it's the same distance from A to C as it is from B to C. Okay. Well, some people might think, okay, well, if it's the same distance there to there and there to there, that's got to be a midpoint, right? But by our definition, it says it's got to be on the segment AB. Well, this point C is not on that segment at all, right? So this would not be a midpoint, okay? So we would say no, and then you could say C is not on the segment AB, okay? Okay, so the next one here it says, why is each of these not a good definition? Okay, so we're going to use our three things that we talked about at the beginning, our three things that make a good definition, and we're going to figure out why each of these is not good. Okay, so it says an endpoint of a segment is a point on the end of the segment. Okay, so if we go through there, an endpoint of a segment is a point on the end of the segment. Well, endpoint's what we're trying to define, so we don't have to worry about that. Segment we've previously defined. Point is left undefined. End. Do we have a definition for the word end and know specifically what that is? I don't think we do. So what I would say here for why it's not a good one, I would say end is not previously defined, so this breaks the first rule. So I would say end is not previously defined, and that breaks the first rule. Okay, next one here, an endpoint on a segment is a point on the segment. Okay, well, an endpoint on a segment is a point on a segment. Okay, well, if we go through our words here, we got endpoint, which is what we're trying to define. Segment we already know, points left undefined, segment we already know, so all those words are good. So that is good for the first rule. Second rule is accurate. Okay, well, is this accurate? So an endpoint on a segment is a point on the segment. Well, if I have a segment here, in truth, the endpoints are these points here, right? So if it says an endpoint of a segment is a point on the segment, couldn't they mean any point that's along that segment? And is any point along that segment really the end point? No, it's not, right? So this one I would say it's not clear, so it breaks the second rule. So you could say Not clear, because it doesn't properly distinguish endpoint, which is what we're trying to define, so endpoint, from any other point on the line. Okay, so that makes this definition inaccurate, so this breaks the second rule for accuracy. So it breaks second rule. Okay, and then the last one here says an endpoint of a segment is one of the points that is farthest from the midpoint of the segment, and there are no points on the segment on one side of the endpoint. Okay, well, if you ask me, that's a mouthful, right? So that's long, it's obnoxious, too much going on there. We could just, take half of that off and still be fine. So I would say that this one breaks the third rule because it's too much information. Okay, so I would say contains too much information, and then that breaks the third rule. Okay. Alright, next thing here is biconditionals. So conditional was when we had the if-then statements. Biconditional, or bi means two, is basically two conditionals put together where we can flip them around and both halves are true. Okay, so we can go in both directions and both are true. So all good definitions can be written as biconditionals or in the two halves like that. Okay, different ways we might see biconditionals. So what it is they're saying, okay, it's true that if we go in the direction P, then Q, and also Q, then P, both of those halves are true. Okay, we can also write that with a double arrow, so P, and then the double arrow stands for if and only if Q. Sometimes they write out the words if and only if, so the first half of the statement, if and only if, then the second half of the statement, and then they can also do P, or whatever the first half is, and then IFF stands for if and only if, and then the second half of the statement. Okay, but really the big thing with biconditionals is it can be written in either direction, and both ways it's true. Okay, so kind of an example here. We have the definition for between. Okay, we've talked about between before. So it says let P, so the first part of this, be D is between A and B. Okay, then they want us to let Q, the second half of this, be, well then AD plus DB is AB. And if we go back to our actual definition of betweenness, that's what it says. Okay, so we've got two halves to this. We've got the term that we're trying to define. So in this case, our term that we're trying to define is between. So the term, and then the characteristic is basically what between actually means. So the term is what we're trying to define. Characteristic is the actual definition of it. Okay, so if we go in the direction P implies Q, our term that we're defining here is the first part. So D is between A and B. Then the second half of this is the characteristic. So then AD plus DB is AB. Okay, so they're going in the direction P implies Q because P stood for the between part. Q stands for the part where they add those two together. So that's that direction. Okay, now we also can flip this and go in the direction Q and then P. So this time they're putting the characteristic first. So the part where they've got the adding. Then our term, or what we're actually trying to define, is at the end, but this is also still true. Okay, so if both halves of this are true, we can say it one way and we can say it the other way, and it's true both times. Then what we can do is we can turn this into an if and only if. Okay, so basically what they do here is the between part, the P, they put at the beginning, and then the end part, the characteristic part, they put at the end, and then they throw that if and only if in the middle, okay? If and only if basically means you can go in either direction and it's still true, okay? So if you ever see a double arrow, that stands for if and only if. You can go both directions, okay? Next thing there is a definition. So it's a definition of circle, and then radius is also mixed in with that. So jot that down on page 79. So it says a circle is a set of points in a plane at a certain positive distance, its radius, from a certain point, its center. Okay, so what that really means here is I'll draw it off to the side here, we've got some point. That point is called the center of a circle, and then some set distance away, the radius, we have a bunch of points all the way around at that same exact distance, and that's the definition of a circle. So if you've got a whole bunch of points all the same exact distance away from the center, so like could have a radius there, could have a radius there, all of those radiuses would be the same, so all of those points together make a circle. Okay, so that would be your definition on page 79. Okay, we've got one more example here. So it says a right angle is an angle whose measure is 90 degrees. Okay, so it wants us to write the conditional part of the definition in the direction term and then characteristics. Okay, so term is what we're trying to define here. So I would say what we're trying to define with this definition would be right angle. Okay, so right angle is our term, and then the part that would be our characteristics, what right angle actually means, would be angle whose measure is 90 degrees. Okay, so if I need to write this in the direction of term and then characteristic, I would go if an angle is a right angle, so that would be the term part, right angle, then its measure is 90 degrees. Okay, that would be the characteristics part. So the term, right angle, the characteristics, 90 degrees. Okay. Then for B, they want us to switch that around. So this time they want us to go in the direction characteristic and then term. So we want to put the measure of 90 degrees part at the beginning and the right angle part at the end. So we could go if an angle is 90 degrees, the characteristic part, then it is a right angle. Okay? And then the next thing there, they want us to write this as a biconditional, so going in both ways with the if and only if in the middle. Okay? So you could start either way. You could start with the term or the characteristic. Typically they start with the term, but it really doesn't matter. I'm going to start with the term. So I go an angle is a right angle angle if and only if, so IFF, it measures 90 degrees. Okay, so biconditional, just take one part, put the if and only if in the middle, then you put the other part. Okay? Okay, so your book page that goes with the assignment is page 80, 2 to 14 even.